Hello friends! Recently, NASA put the images taken by JamesWebb telescope in public domain. These are truly mesmerizing, unprecedented photos, which tell us interesting things about the universe. One of these photos gives us the oldest glimpse of the universe. We can see 13.1 billion years into the past. In another, we discovered an alien exoplanet where water, or H2O, has been found. Come, let's try to understand these new discoveries in today's videos.
The James Webb Space Telescope is the largest and most powerful space science telescope ever built. Every image is a new discovery, and each will give humanity a view of the universe that we've never seen before. So the Webb is able to look at the formation of the first stars and the first galaxies. The Webb is tremendously exciting. Light from other worlds, orbiting stars far beyond our own. It's astounding me in many ways.
Friends, this telescope cost about $10 billion. It took NASA 25 years to work out its design and development. And most interestingly, the spot where this telescope is located currently, it is operating at the temperature of 266.75 degrees C. It is so cold that it is almost at the absolute zero temperature of 273 degrees C. Temperature cannot fall beyond that. It is only a few degrees warmer than that. To maintain this temperature, the James Webb Space Telescope doesn't orbit around Earth, like the Hubble Space Telescope. Rather, it orbits around the Sun. About 1.5 million kilometers from Earth, there's a point known as the L2 point. It is always in the Earth's shadow, in a way that it can safely orbit the Sun. As you can see in this video, to block out the rest of sunlight, a sun shield has been attached behind it. It's nearly as big as a tennis court. Do you know what is the focal length of this telescope? Those of you who use DSLR cameras as a hobby would know the lens of those cameras usually has the focal length somewhere around 24 millimeters, 35 millimeters or 50 millimeters. The focal length of the James Webb Space Telescope is more than 2,500 times of it. 131.4 meters. Meters, not mm. Its main mirror weighs around 705 kilograms. I have discussed these technical aspects in the previous video on James Webb Space Telescope. I will put a link to it in the description below. If you want to know how this telescope was built and how it works, let's get straight to the point and talk about the photos taken by this telescope. Before this, let me remind you that this is our electromagnetic spectrum. Different EM waves have different wavelengths. In it, there is a tiny spectrum of visible light. The light which we can see with our naked eyes. The rainbow colors: violet, indigo, blue, green, yellow, orange, and red. This wavelength ranges from 0.38 to 0.7 micrometer. Wavelengths higher than red are known as infrared, and the wavelength on which this James Webb Space Telescope can take pictures in ranges from 0.6 to 28 micrometers. There is a small overlap with the visible light, but mainly, this telescope works with the infrared portion. As I told you about its advantage in the previous video, you can look through the gases and clouds because of the larger wavelength of the infrared light. The longer the wavelength, the easier it is to go through objects, such as radio waves, whose wavelength is measured in kilometers. We can listen to them through the radio. Those waves can travel through our homes and walls. 2 infrared cameras are mounted on this telescope. The near-infrared camera, NIRCam, to capture the shorter infrared wavelengths, and the mid-infrared instrument, MIRICam, to capture the longer infrared wavelengths. Depending on the camera used by the telescope, the photos vary. Look at this photo. This photo, taken by the NIRCam, truly breathtaking. It went viral on social media. When the photos were released by NASA, but the same photo was taken by the MIRICam as well. And the same thing looks like this on MIRICam. The dust clouds which were visible don't show up much on the MIRICam because the wavelength capture by MIRICam is longer. So it is easy for it to pass through objects, enabling us to look through the clouds. You might ask now, what is the thing in the photo? What are we looking at? Friends, the answer to it is, we are seeing the death of a star. Yup, that's correct. We can see the star dying. There are 2 stars in this photo, orbiting around each other. The brighter star of the two is at the early stages of its life, and the dimmed star is dying. While dying, over the last thousands of years, this star has been releasing clouds of gases and dust. The cloud of the gases and dust is known as the planetary nebula, and because the two stars are orbiting each other, the cloud keeps getting swished around. Similar to how you mix sugar into the water, because of the gravitational pull of both stars, this is the shape of the cloud. It is interesting to note that in the NIRCam photo, you can see only one star, and you can see the cloud clearly. But in the MIRICam photo, the cloud is quite muted, and you can clearly see the two stars. As I explained, because of the longer wavelength, we can see the center of the dense cloud. If this is the first time you're hearing about stars dying, shocking, isn't it? I'd like to tell you that similar to the life cycle of humans, childhood, teenage, adulthood, old age, and then death, similarly, stars have a life cycle too. Our sun is a star as well. It is quite young now. About 5 billion years later, our sun will become a red giant. After becoming a red giant, it too will go through the same stages that these stars are going through in this photo. It'll become a planetary nebula, after which it'll be a white dwarf, and then the end. Red giants are bigger in size than an average star. When our sun will turn into a red giant, it will swallow the planets of Venus and Mercury. And Earth will no longer have living conditions. But do not worry, humans have 5 billion years to discover some technology which can push back Earth's orbit. But that's for later. There's no use talking about it now. Let's talk about the rest of the photos. The first photo released by NASA was this one. It is perhaps the most historic photo too. This photo gives you a glimpse from 13 billion years ago. After seeing this photo, American President Joe Biden said that it is a new window into the history of the universe. It's a new window into the history of our universe. And today, we're going to get a glimpse of the first light to shine through that window. In this photo, we can basically see a galaxy cluster, SMACS 0723. The galaxies closer to our camera have a high gravitational force such that they are distorting the light coming behind them. It creates a magnifying glass of sorts. This phenomena has been named gravitational lensing. With its help, we can see objects behind it. It isn't a photo which was simply clicked by the telescope as is. Similar to how you point your camera, tap a button and take the picture, it's not so. It took 12.5 hours to take this photo. Actually, the telescope had to take several different images at different wavelengths and later combined them. And we're now seeing this combined photo. In it, the galaxies that appear redder in color are farther from us. The redder the galaxy, the farther it is. While we're discussing the distance, look at the next photo. This has been named Stephan's Quintet. It is a cluster of 5 galaxies. The prefix quin is used for the number 5, such as quad is used for 4. This quintet is more of a quadtet, because the leftmost galaxy among them are 40 million light-years away from us, and the other 4 galaxies are about 290 million light-years away. As you can see, the photo of the leftmost galaxy looks more HD if you zoom into this photo, while the other 4 galaxies look quite blur. These 4 galaxies are so close to each other that the dust and stars present in them have started interacting with each other. We can see the effect of their gravitational forces on one another. For scientists, this is immensely interesting to see. The scientists want to know what happens when galaxies get so close to one another. Next is the most beautiful photo till now. In it, we can see the birth of a star. After seeing the death of a star, we can now witness the birth of a star. The mountain range kinda thing that you see have been named as cosmic cliffs by scientists. This is again a nebula. Nebula means a bright area formed by the clouds of dust and gases. You can think of it as a big shiny cloud. In Hindi, it is known as Niharika. This specific nebula is named Carina Nebula. If we go back to the life cycle of a star, you'll see that a star is born at the stage of a stellar nebula. In this photo, we can see the birth of the stars. The red dots in this photo are basically growing infant stars. You can see this from NIRCam and MIRICam both. Friends, now let's come to our most interesting photo. It is not even a photo, but this has piqued the curiosity of scientists the most. It is a spectrographic data of the planet WASP 96b. It is an exoplanet 1,150 light-years away from us. Exoplanet is a planet that lies outside our solar system. Apart from the two cameras, the JamesWebb telescope is equipped with a NIRISS. NIRISS stands for Near Infrared Imager and Slitless Spectrograph. Spectrograph is an instrument which measures the intensity of the various wavelengths of light. For 6.5 hours, the NIRISS measured the light coming from this planet. The result of the measurement was this light curve. The data plotted on this graph tells us that there's water on this planet, H2O. Additionally, there's some haze and clouds as well. You might wonder, how can we determine whether a planet has water or not, simply by measuring light, even though we haven't even seen its photo? The answer to it is very simple, friends. As I told you at the beginning of the video, each color has a distinct wavelength of light. And the colorful world that we see around us, it's all an illusion created by the wavelength. For example, why do we see trees, plants, and leaves as green in color? Because they contain chlorophyll. Chlorophyll is unique because it absorbs red and blue color wavelengths, and the wavelength which it cannot absorb, that's the green color, is what we can see. Similarly, the water in oceans looks blue to us, because it is water's property to absorb the other wavelengths of red, yellow, and orange, and since it cannot absorb the blue wavelength present in light, we see it as blue in color. The same logic can be applied in reverse as well. If we pass light through a leaf, in the light on the other side, the red and blue wavelengths would be blocked. If we measure it through a spectrograph and create a chart, we will be able to see a certain pattern with which we can draw the conclusion that if the same pattern is repeated somewhere else, it is most likely that the second thing is similar to a leaf, or may even be a leaf itself. The light from the WASP 96b was captured by this telescope. A graph was prepared on the spectrograph, and the blocked wavelengths of light were analyzed. Scientists know the exact ratio of blockage of wavelengths to know which molecule the light had to pass through. That's why the graph that you can see here has the wavelengths of light on the x-axis, and the amount of light blocked is on the y-axis. The scientists knew that if a certain amount of light is blocked at a wavelength, it was evidence of the presence of H2O. The same thing happened here, and so we can conclude that there's water on this exoplanet. If you are happy knowing that the presence of water on this planet may signify the presence of life on it, that we might find aliens there, don't be so happy. Because this planet is not habitable. Scientists have discovered other facts about the planet. First of all, this closeness of the planet to its star, the size of the planet. With those parameters, they have estimated that the temperature on that planet is more than 530 degrees. So the chances of finding aliens on this planet are next to none. But over the next few months, the JamesWebb Space Telescope will analyze another planet. It will be pointed towards a new planet to take pictures of that planet. In our Milky Way, in our galaxy, there are about 300 million potential habitable planets. Planets where humans can survive, where life can be found. But practically, with what we have seen and observed in Milky Way, we have analyzed only about 5,000 exoplanets. Not even the potentially habitable 5,000, we have observed about 5,000 exoplanets in total, although several of them are potentially habitable. In November 2018, researchers had found that of all the exoplanets observed by now, one of those planets have the highest chances of being a habitable planet, on which life can be found. It resembles Earth the most. This planet was named TRAPPIST-1e. Scientists claimed that if we were to look for habitability, this would be the most worthy candidate. This exoplanet is merely 40 light-years away from us. Merely is such a misnomer. 40 light-years is equal to 380 trillion kilometers. But relatively speaking, 40 light-years isn't very far compared to the other exoplanets. The star around which this planet orbits isn't like our Sun. Instead, it is an ultra-cool dwarf star, named TRAPPIST-1. It is quite cooler than our Sun, that's why it is known as ultra-cool. But the distance between the star and this planet is lesser than the distance between Earth and the Sun. The temperature on this planet remains in the habitable zone. On top of it, the dimensions of this planet is quite similar to Earth's. Its radius is 91% of Earth's radius. Its total mass is 77% of Earth's mass. Density is 102% of Earth's density, and the gravity on the surface is 93% of the Earth's gravity. It has also been confirmed that there is a surface of solid rocks on this planet. The temperature is so cold on this planet that liquid water can exist on it, but not so cold that it would freeze. Over the next few months, the JamesWebb Space Telescope will analyze this exoplanet in detail. It will check whether its atmosphere contains carbon dioxide, methane, and water vapor or not. If a certain combination of these gases is detected, it will help us to conclude that there might be life on that planet. Let's wait for the future discoveries made by this telescope. But one this is for sure, the scientists believed that if any exoplanet has to sustain life, 3 main things should be present there: liquid water, a solid surface, and an atmosphere where a certain combination of these gases is present. I hope this video was as informative as always. If you liked this, go watch the other video as well, to know more details. Let's meet in the next video. Thank you very much.